Hello everyone, welcome to your physics class of class 7th. I hope you all will be fine. Students, today in this video we will complete the question answers of lesson number 6. Okay, so let's begin our class. Question number 1, what do you mean by a vibratory motion? The oscillatory motion in which the body assumes a new shape during its motion is called vibratory motion. Question number 2, what is sound? Answer, sound is a form of energy which produces a sensation of hearing. Question number 3, how is sound produced? Sound is produced by vibrating bodies. Question number 4, describe an experiment to show that each source of sound is a vibrating body. So this is your answer for question number 4. So you have to make this diagram also. Question number 5, name two sources of sound. So each vibrating body is a source of sound. We, the human beings, produce sound when our vocal cords vibrate on blowing air through them by our lungs. Some animals like birds, frogs, etc. also produce sound due to vibration of their vocal cords. But bees do not have the voice boxes. They produce sound by moving their wings up and down very fast. Question number 6, how do we produce sound? So our throat has a larynx. The voice is produced in the larynx. Larynx is also called the voice box. It is designed to produce voice. It is a box-like structure with walls of tough tissues. Inside two folds of the tissues, there is a gap. They are the vocal cords. When we breathe, the vocal cords become loose and the gap between them increases. When we talk, shout, or sing, the cords become tight and hence they vibrate, thus produce sound. Okay. So this is a figure, but you don't have to make this picture. Now, question number 7. The bees do not have voice boxes. How do they produce sound? The bees do not have voice boxes, still they produce sound. This happens by the vibration produced by the quick movement of their wings. Bees buzz while flying and depositing pollen among flowers. Question number 8. Can sound travel through a vacuum? Describe an experiment to explain your answer. So this is your experiment for this answer. Okay. Now, question number 9. Describe an experiment to show that sound can travel in water. You can take the screenshot of these answers and then you can complete your work. Question number 9. Take a tub filled with water. Hold a bell in one hand and dip it in water. Keep one eye of your ear gently on the surface of, keep one of your ears gently on the surface of water without letting water into the ear. Now bring the bell inside water. You will be able to hear the sound clearly. This shows that sound can travel through liquids. Describe an experiment to show that sound can travel in a solid. Now take two empty ice cream cups. Make a small hole at the bottom of each cup. Here at the bottom of each cup and pass a long thread through them. Tie a knot or matchstick at each end of the thread so that thread does not slip out through the holes. This makes a toy telephone. Okay, now use a toy telephone as shown in the figure and talk to your friend. You will be able to hear the sound of your friend. This shows that sound travels through the thread and reaches your ear. The sound can travel through a solid. Question number 11, can two persons hear each other on moon surface? Give reason to support your answer. No, we cannot hear each other since sound requires medium for transmission. It cannot travel through vacuum. And on moon surface, there is vacuum. Question number 12, what is a longitudinal wave? In a longitudinal wave, the particles of air vibrate to and fro about their mean positions in the direction of travel of sound, in the direction of propagation of sound. Question number 13, define the terms amplitude, time period, and frequency. So the maximum displacement of a wave on either side of its mean position is called the amplitude. The time taken to complete one vibration is called the time period. And frequency, one number of oscillations made by a wave in 1 second is known as frequency. Write the audible range of frequency for the normal human ear. So it is 20 Hz to 20,000 Hz. What are ultrasonics? Can you hear the ultrasonics? So the frequencies higher than 20,000 Hz are called ultrasonics. We cannot hear the ultrasonic sounds. What are infrasonics? Can you hear them? The sounds of frequency lower than 20 Hz are called infrasonics and we cannot hear infrasonic sounds. Question number 17. How can a bat make use of ultrasonic waves to find its way? So this is your answer for this question. Now name the two characteristics of sound which differentiate two sounds from each other. So the two characteristics of sound, the sound is characterized by its amplitude and frequency. Now depending upon the amplitude and frequency of the sound, the following two characteristics of sound are loudness and pitch. Question number 19. On what factor does the loudness of a sound depend? Loudness of a sound depends on the amplitude of the vibration of the vibrating body producing the sound. Question number 20. How does the loudness of sound produced depend on the vibrating area of the body? Okay, so this is your answer. Greater the area of the vibrating body, louder is the sound produced. Okay, and this is the example. Now question number 21. The outer case of the bell in a temple is made big. Give reason. Because the outer case of the bell is made big so that there is a multiple reflection of sound and sound can be amplified. Question number 22. State the factors on which the pitch of a sound depends. So pitch of a sound depends on its frequency, that is on the frequency of the vibrating body. Question number 23. Differentiate between a high pitched sound and a low pitched sound. Higher the pitch, shriller is the sound. Lower the pitch, the flat or grave is a sound. Question number 24. How does a man's voice differ from a woman's voice? A female voice is shriller than a male voice because of higher pitch. Higher is the frequency, shriller is the sound. Female has higher frequency. Now question number 25. State the characteristics which differentiate two sounds of the same pitch and loudness. The quality of this is a characteristic of sound which distinguish the two sounds of same pitch and same loudness. Question number 26. You recognize your friend by hearing his voice on a telephone. Explain. We can recognize our friend by hearing his voice on a telephone due to quality of sound or pitch of the sound. Question number 27. A musician recognizes the musical instrument by hearing the sound produced by it even without seeing the instrument. Which characteristic of sound makes it possible? It is a pitch and quality that helps a musician recognize the musical instrument by hearing the sound produced by it even without seeing the instrument. Now question number 28. Describe an experiment to show that the production of sound having low and high pitch. So this is your answer. Question number 29. How does a musician playing on a flute change the pitch of sound produced by it? Answer. In a musical instrument like flute, clarinet, the pitch of sound is changed by changing the length of vibrating air column when different holes in it are closed. Question number 30. Why are the musical instruments provided with more than one string? The string instruments are provided with a number of strings of different thickness and under different tensions so that each string produces sound of different pitch. Question number 31. How can the pitch of a sound produced in a piano be changed? In a piano, the string is struck to make the string vibrate and produce sound. The pitch of sound produced can be changed by stretching or loosening the strings of the piano. Question number 32. Explain why you can predict the arrival of a train by placing your ear on the rails without seeking it. Answer. The sound produced by the moving wheels of train travels much faster through the track than through the air. Therefore, they hear through the track much before it is heard through the air. Okay. Now, next question. Question number 33. Write the approximate speed of sound in air, water and steel. So this is for air 330 meter per second, liquid 1500 meter per second and solid 5000 meter per second. Question number 34. During a thunderstorm, the sound of thunder is heard after the lightning is seen. Why? Because the speed or the velocity of light is 3 into 10 raised to the power 8 meter per second, whereas the velocity of sound is 332 meter per second. First we see the flash of light and then we hear the thunder. Question number 35. Describe an experiment to estimate the speed of sound in air. So this is your experiment. To estimate the speed of sound in air, we choose two hills A and B about a kilometer apart. A person at the hill A fires a gun. Another person at the hill B starts a stopwatch as he sees the flash of the fire and stops it on hearing the sound. Thus, he measures the time interval between the seeing of flash and hearing the sound. Okay, let it be t second. Then measure the distance between the hills A and B. Let it be s meter. Therefore, speed of sound is equals to distance upon time, and experimentally it is found that the speed of sound is nearly 330 meter per second. Now, question number 36. Can sound travel through solids and liquids? In which of these two does it travel faster? So, sound travels with highest speed in solids and lowest speed in gases. Question number 37. What do you mean by reflection of sound? So, reflection of sound, when a sound waves strike a rigid surface, it retraces from its path, is called reflection of sound. State one use of reflection of sound. Reflection of sound is used in making the speaking tube, megaphone, soundboard, and trumpet. Question number 39. What is echo? Echo is the sound heard after reflection from a rigid surface such as a cliff, a hillside, the wall of the building, etc. Question number 40. What minimum distance is required between the source of sound and the reflecting surface to hear an echo? Give reason. Since sound has to travel an equal distance in going up to the reflecting surface and in coming back from the reflecting surface. Therefore, it must travel nearly 33 upon 2, that is 16.5 meter either way. Thus, to hear the echo clearly in air, the reflecting sound should be at a minimum distance of 16.5 meter from the source of sound. Question number 41. List 4 substances which are good absorbers of sound. So, when sound falls on sofa, the fluffs and means fluffy items and light substances such as clothes, paper, thermocol coating of plaster of Paris, carpets, curtains, furniture, wood, etc. They absorb the sound to a good extent, and these are called good absorbers of sound. Question number 42. List the measures that you will take while designing a soundproof room. So these are the measures. First one is the roof of the enclosure must be covered by plaster of Paris after putting the sheet of thermocol. Now second, the wall of the enclosure should be covered by the wooden strips. Third, the floor must be laid down by thick carpets. Fourth, the machine parts of all the electrical equipment such as fan, air conditioner, etc. must be placed outside the enclosure. Thick curtains should be used to cover the doors and keep them closed. And sixth is, thick stripping must be used to cover the openings of doors and windows. So these are your answers of lesson number 6. Now what you have to do, you have to complete this work in your notebook. Okay, and you can complete by pausing the video or simply by taking the screenshot of the answers, and you can complete your work in your notebook. Okay, so this is all for today. Thank you.